Okay, so again the same problem. Okay, the same truss A, B, C, D, E. The loads are W1, W2, W3, same loads, and I want to find the load in the member. I want to find the load in the member, the same member. I want to find the load in the same member, FCE. I want to find the load in the same member, FCE. I want to find the load in the same member, FCE. Okay, so this I'll do one thing. I want to find the load in the member, FCE. Now, please, all of you see here. Step one. Step one. Same as method of joints. What do you mean by same as method of joints? What is the step one in method of joints? Find the support reactions considering the entire truss to be a single body. Whatever you have done there, here also the same step. First, find out the support reactions at support A and support B. What are the supports you have? Find out the support reactions. Already we have done, so I'm not going to do that. Okay. Next, step two. Section R, cut the truss. Section R, cut the entire truss. Section or cut the entire truss. Section or cut the entire truss into two parts. Section or cut the entire truss into two parts. Section or cut the entire truss into two parts, such that member of interest is also sectioned. Member of interest is also section. Section or cut the truss, entire truss into section or cut the entire truss into two parts, such that member of interest is also sectioned. What is my member of interest, sir? What is my member of interest? C is my member of interest. So now cut the truss such a way that what's that? Such that member of interest is also section. What's the member of interest? Member of interest is also section. What's the member of interest? What's the member of interest? Member of interest is also section. What's the member of interest? CE. So you should cut such a way that CE is also cut, right? Now, please all of you see here. What are the possibilities? What are the possibilities to cut the truss? See, by cutting the CE. See, I'm taking generally, right? See, one way of cutting, I can cut like this. I'll say this is 1, 1, 1, 1. I can cut like this. Is the CE section? Yes, it is section. Okay, so 1, 1. Next. That's the only condition told, right? Next, what is the next possibility we have? Let me go with black. What's another possibility we have? I can section like this. Okay. So let us say this is 2, 2, 2, 2. Is my member C section or not? Yes, it is getting section. Okay. Next, what else is the possibility? I'll say like this. There's no need to be a straight line, so you can cut in any fashion you want. Okay. Can I cut like this? Yes. This is the third possibility, because the only rule is this should be section. I'll come for the next one, sir. I'll come for the remaining things now. Okay, 3, 3. Next, what else are the possibilities we have? Can I cut like this? Can I cut like this? Yes. 4. This is the fourth possibility, because it is section here. Next, what else are there? Yeah, even C. I can cut like this. 5. Okay, yes, this is the possibility that is done. Okay, anything else? Okay, fine. I have some 5 possibilities. Okay, now which is permitted? See, all are cutting my section. See, what's that we told? Section are cut the entire truss into 2 parts such that member of interest is also section. Okay, so I have made the 5. Okay, now listen. Step 3. What is that? Step 3. During sectioning, take care that any joint, is not isolated. Every section should contain at least 2 joints. Every section should contain at least 2 joints. Every section should contain at least 2 joints. That is, every section should contain at least 2 joints. What's the meaning of this? Listen. During sectioning, take care that any joint is not isolated. That is, every section should contain at least 2 joints. Listen, see. What happens if, suppose, let us say one joint is isolated. Suppose, let us say, if I have gone with section, this is 4-4, now. 4-4. If suppose I have gone with section 4-4, if I have gone with section 4-4, what happens if I have gone with section 4-4? See, only joint C is there on this side. Remaining A, E, D, B. Remaining 4 joints are on this side. 1 on that side, 4 on this side. Suppose I have gone with 4-4. What is the problem? As C is isolated, if you draw the free body diagram of this side, it is nothing but C. And again, you are getting what is that? Free body diagram of C, which is nothing but giving me a coplanar concurrent force system. Again, I can solve only 2 unknowns. So whenever suppose if I go with even 5-5, what is happening? Only E is on this side, remaining 4 are on that side. If I draw the free body diagram of E, again what is it I'm going to get? Coplanar concurrent force system, and again I'll get only 2 equations of equilibrium. Are you getting me? So that means it will again become a method of it will become again method of joints. Hence this sectioning 4-4, and 5-5 are not permitted. Hence this sectioning 4-4. Hence this section 4-4 and 5-5 are not permitted. Why? Because in 4-4 one joint is getting isolated. Here one joint is getting isolated. Again it will give me a coplanar concurrent force system. That is nothing but method of joints. So both 4-4 and 5-5 are not allowed. What about 1-1? See, 2 on the above, 3 in the below. Yes, okay. Go with 2-2. 2A and C on this side, DEB on this side, S permitted. Go with 3-3. AE on this side, CDE, B on that side. Okay, so any of these 3 are permitted as of now. Okay, so first step, section, what's that? Same as method of joints, find the support reactions. Now section or cut the truss into 2 parts such that member of interest is section. During sectioning, take care that none of the joint is isolated. Next, step 4. Listen. Step 4. What's step 4? Draw the free body diagram of either side of the or either part of the section. Draw the free body diagram of either side of the section. So next, what is the step? Draw the free body diagram of either side of the section. Now, so all the 3 are permitted. I cannot go with 3. I'll go with any one, your wish. So I'll go with the first one. Okay. Now, which one is valid? We'll see. Okay, for the time being, I'll go with first one. Okay. So what we told, draw the free body diagram of either side of the section. So what's there? Either CD or AEB. See, Y3, I'll go with 2. Whichever side is simpler, that is preferable. Okay, your wish. I will justify which side to take and all. First, let us go with any side. Okay. Now, for the time being, I'll go with CD. So if I remove this and if I draw the free body diagram for this, what are the 2 joints on this side? Only CD. Only CD is there, right? Now, first Free the body from everything and draw the sketch. Free the body from everything and draw the sketch. Free the body from everything and draw the sketch. Free the body from everything and draw the sketch. Free the body from everything and draw the sketch. Okay. So this is my C, this is my C, and this is my, okay. This is my C and this is my D. Okay. So C, D. Only two joints are there on this side. So I have taken the two joints. Okay. Next. Actions. Tell me what are the actions. Now forget this. On the side CD, on this CD, what are the actions? At C, I have a load W1. At C, I have a load W1 vertically down. At D, I have a load W2, which is acting at an angle theta with the horizontal. Now. At C, I have a vertical load W1. I have a vertical load W1. At D, what is happening at D? There's a load at an angle. See, at C I have a load W1. At D I have a load W2 making an angle theta with the horizontal. These are the two loads. Yes or no? So there's no mass, nothing. The applied loads are only these two. So those are the actions. Free the body from everything and draw the sketch. CD done. Action W1, W2 done. Next, reactions. Go for the reactions. So what are the reactions I'm getting? Listen. I have gone with which number? 1, 1. I have gone with which section? 1, 1. Now check where this 1, 1 is cutting. See, it's cutting the member AC. See, this CD is having connections with what? AC member. It's being sectioned. It's having a connection with the CE member. It's being sectioned. It's having a connection with DE member. That is also removed. It's having a member with the BD. So that is also removed. So these four are applying forces on the CD member, right? So as these four members are now cut and removed. So in place of those four members, keep the appropriate reactions. So how is the member going to apply the load on it? Along the member. The line of action of the force will be along the member. In which direction? It may be, sir, I don't know, but I will take them as, towards the joint. I'll take them as what? Towards the joint. Okay. So I have 4 here. What is that? See, it's an equilateral triangle. Both are equilateral triangles, so they are making an angle of 60. What is it? 60 with the horizontal, 60 with the horizontal. Okay. CA, CE, DE, DB. Okay. Your wish, whatever terminology you write, it's fine. Okay. So I'm writing directly what's that? I have 4. One is this member. What is this member? FAC. Next, one more here. What is this? FCE. Next, here one more. That is FDE. Next, one more here. That is FBD. Okay. So FAC or CE, whatever you write, I don't have any objection. FCE or EC. FDE or ED. FBD or DB, whatever you wish. So 4 members, I got the 4 support reactions from the 4 members. Are you okay? So free the body from everything and draw the sketch done. 2 actions done. 4 support reactions. 4 members are there. 4 support reactions I got. Now tell me, what is this system? What is this system? It's nothing but a coplanar general force system. It's nothing but a coplanar general force system. If I resolve, maybe whatever you do, it's a coplanar general force system because all the forces are not acting at the same point and all the forces are not parallel to each other. So I can call it as a coplanar general force system. For a coplanar general force system, how many equations of equilibrium I have? Don't say I didn't tell for me and all. For a body, it can undergo only 2. Translation, rotation. Translation, resultant is, if it is in static equilibrium, resultant is 0, which gives me 2 equations, Rx, Ry, because it's a planar body. Rotation, it's in static equilibrium, so it will give me 1 equation, that is moment. So in total, how many are there? Either CPFS or CGFS. We have a body, so we have 3 equations of equilibrium. If it is a CCFS, coplanar concurrent force system, I'm treating it as a particle, only 2. Remaining, we have only 3. For a plane, at maximum 3. 3 DYF, so 3 restricted. Yes sir, I showed the DYF. X, Y and rotation, all the 3 are restricted. So I got 3 equations. And how many unknowns are there? 1, 2, 3, 4 unknowns are there. So can I solve this? No. What to do? At maximum, I have 3 equations of equilibrium. So while sectioning, take care that not more than 4 unknowns are created. Sorry, not more than 3 unknowns are created. So while sectioning, take care that not more than 3 unknowns are created. Now see, 1 is also not valid. Then who are valid? Next, go with the 2. How many are there? 1, 2, 3. How many unknowns are being created? It is cutting only 3 members. That means it will create only 3 unknowns. So 2, 2 is permitted. Go with 3, 3. 1, 2, 3, 4. Again 4 members it's cutting. So 3, 3 is also not permitted. So what's the best one? What's the best one? Not the best one. What is the only possible one? 2, 2 is the possible one. How many are there? 3 are there. So what's the last point? What's the last point? Step 5. Step 5. Section in such a way that not more than 3 unknowns are created. Section in such a way that not more than 3 unknowns are created. Okay, so what's the first step? Same as method of joints, find the support reactions. Now cut the entire truss into 2 parts such that the member of interest is sectioned. Next, take care that, what are the things? Take care that none of the joint is isolated. That means at least there should be 2 on both the sides. Next, while sectioning, take care that, what's that? Not more than 3 unknowns are created. What happens if there are more than 3 unknowns? You cannot solve it. Okay, so keep those 3 in mind. Member of interest need to be sectioned. None of the joints should be isolated. Not more than 3 unknowns are created, so that you can solve the problem. Apart from it, I have one more that I will tell you while solving the problem, so that it will become easy for you to solve. Okay, it's not a condition or constraint, that I will explain there. Okay, see the same diagram. I have just redrawn here. Now please all of you see here. What is this? Just take this force system. What is this? All the 3 forces are passing through. The same point C. That means, can I say this is nothing but a coplanar. Only these 3. Coplanar concurrent force system. This is nothing but a coplanar concurrent force system. I'll say CCFS1. This is a coplanar concurrent force system 1. Similarly, take this. This is nothing but a again coplanar concurrent force system. That is a CCFS2. Can I reduce all the coplanar concurrent forces into a single force? Can I reduce or not? So if I reduce all the coplanar concurrent forces into a single force, what will happen? That single force, that's called a resultant, will pass through which point? The same point C. That means if I reduce the CCFS into a single force, that is the resultant. How is the resultant going to be? So I don't know the direction and all, but definitely it has to pass through. The point C. So let us say this is the resultant R1. For this CCFS, this is the resultant R1. Similarly, if I solve all this coplanar concurrent force system to CCFS2, it will all become into again a single force. Again, some direction, I don't know, right? Some direction. Again, it will become how much? Resultant R2. I can replace it with resultant R2. This is resultant R2. So the CCFS completely can be replaced with a single force, that is R1. This CCFS completely replaced with a single force called R2. Okay, that means finally I have, this is my body. On this, how many forces are being acted? I have 2 forces. What are the 2 forces? At C, this end, I have 1 force R1, and at this end, I have 1 more force. This is resultant R1. This is resultant R2. At this end C, I have 1 force. At this D, I have 1 more force. That means all these forces is equal to 1 force. All this is equal to another force, R1, R2. Now, what is CD? CD is the member of a truss. Okay, and that member is in which equilibrium? This member is in which equilibrium? Static equilibrium. Under the influence of how many forces now? How many forces are acting on it? At C there is 1 force, and at D there is 1 more force. Okay, so under the influence of 2 forces, this member or the body CD is in static equilibrium. Whenever the body is under the influence of 2 forces, For it to be in static equilibrium, how should be the two forces? How those two forces should be? They should be equal in magnitude. Next, second, opposite in direction. And third, they should have same line of action. These three conditions need to be satisfied. What's this? Equal magnitude, opposite in direction, and again same line of action. Equal in magnitude, opposite in direction, same line of action. But this force need to pass to the point C and this force need to pass to the point D. When those 2 points are fixed, what is the line? What can this line of action pass into those 2 points? See, when our 2 points are fixed, they can have only one straight line through them. So this is the line of action. So this is the only possible line of action. What's the only possible line of action? Along the member. What's the only possible line of action? Along the member. What's the only possible line of action? Along the member. The only possible line of action is along the member. That means, how should be both the members? Please, all of you, see here. 1 minute, see here. How should be the forces? Please, all of you, see here. How should be the forces? Either see, equal in magnitude and opposite in direction. See, equal in magnitude, opposite in direction. Either in this fashion. See, equal magnitude, opposite direction, same line of action, are like this. The only two possibilities, either like that, are like this. Fine. Very good. Okay. Same. Okay. Now, please, what's that? Both the forces should have equal magnitude. Opposite, either like this or like this, opposite direction and same line of action. So this member is under compression. This member is under what? Compression. And this member is under tension. And this member is called as a strut. And we call this member under tension as a tie. If the member is under compression, we call it as a strut. If the member is under tension, we call it as a tie. That's why I told while taking the forces, only possibility to have the force is along the member. Otherwise, it will not be in static equilibrium. Okay. So the only possibility, because if you apply in any way, it will start rotating. It will not be in static equilibrium. Okay. So the only possibility to have it is in along the member. Either the member will be in compression or tension. So both are nothing but what? Compression and tension are nothing but what? Axial stress. That's what I told in the starting. There is no bending stress. There is no shear stress in the member. The member will have only what? The member will be under only what? Axial stress. The member will be subjected only to what? Axial stress. The member will be subjected only to axial stress. The member is subjected only to axial stress. Everyone is able to follow me? Are you understanding me? So the members, all the members either will be under compression or tension. Okay. So what's the first one? The members, the load in the member will be only along the line, along the axial direction of the member. That is either compression or tension. Okay. How to find out also, I will tell that. Okay. So as they are only along the member, they will have only what stress? Axial stress. There is no bending or shear stress in this one. What's the advantage with having only axial stress? That stress will be distributed uniformly throughout the cross section. Hence, the material will not get wasted. So that's a beautiful technique what they have found out by using this construction method of a structure. Okay. So that's why you prefer trusses as the basic construction method in any big bridges. Wherever you go, you'll see a truss. Okay. So this is the one point what I want to tell for you. Next, the second point. What's the second point? Now please see. See, let us say this is a member, this is the one joint, and this is the other joint for it. I'm taking the first one, this is for the second side. For the first side, this is the member, this is the joint on this side, this is the joint on this. We drilled a hole and we kept a pin, okay, this pin, okay, these are the two pins, this is the member, okay. Now let us say the member on this side, is pulling it, come, it is pulling it, let's say it's pulling it like this, Now, what will this joint do? If it doesn't have any support, it will go in this direction. If it doesn't have any support, it will go in this direction. But this member is attached to it. So what this will do? It will go as it is in the hole. It will go as it is pulling. It will pull it. See, as this fellow is pulling me, I will pull this fellow. It will go and pull this. It will go and pull this member. Now, what happens as it starts pulling this? Now tell me, I'm pulling it, it will pull me. In turn, what I will do? See, this fellow is pulling me, so I will pull this fellow. In turn, what that fellow will do? He will pull me back. That means, see, it is pulling it. So, this joint will pull it. In turn, for this action, see, for that action, this is a reaction. That guy is pulling, this is an action, right? For this action, what will happen? This will pull it back. That guy is pulling it. This guy will go and pull him. So what will this fellow do? He will pull him back. Now, as this guy is getting pulled, he will pull him back. Now, what he will do? He will go and pull this fellow. Now, as this guy is getting pulled, what he will do? In turn, he will pull him back. First, what he will do, as he is pulling, he will go and see if there is no guy, he will come off. As maybe there will be another member, that fellow will pull him like this, and he will go and pull him in this direction. So, what's the final conclusion I'm making is? So, if there is a force which is away from the joint, if there is a force away from the joint, what will happen? See, when there is a force away from the joint, both are pulling it away. So the point will be under tension. See, whenever the force is away from the joint, both the joint and member are under, both the member and joint are under tension. If suppose this guy is pushing it, so what this fellow will do? He will go and push him. In turn, what will happen as it is pushing? It will offer a resistance force. Like this. And in turn, this fellow will go and push this joint. In turn, the joint will oppose it. And again, it will go and push that, and he will resist it. That means, if the force is towards the member, if the force is towards the joint, so that member or the joint will be under compression. Are you understanding me? Are you getting me? See, in the problem, what I told, always take the force towards the joint or towards the member. Whatever is given, you take it towards the joint or member. If it comes positive, my assumed direction is correct. It is towards the member or towards the joint. Hence, it is under compression. If suppose I got a negative, I have taken towards the joint and solved the problem. I got it negative. That means it is not towards the joint. It is away from the joint. It is away from the joint or away from the member. That means it is under tension. So remember in the problem, you follow one thing, either towards the joint or away from the joint. What I am going to do, I will take always towards the joint. Blindly, I won't think anything. Whether it is towards or away, I won't sit and analyze there. Okay. So I will always take the force while solving the problem. The reaction force along the member is towards the joint, towards the member. In the end, if it comes positive, I won't go back and see, so what I have taken under. I know I have taken all the way towards the joint. If it comes positive, my assumption is correct. It is towards the member and towards the joint. So they are under compression. If it is coming negative, that means my assumption is wrong. It is under tension. It is away. It is under tension. This is what I will follow. Always take the reaction force. Take the force towards the joint. Always take the force towards the joint. towards the joint. If it comes positive, my assumption is correct. If it comes positive, my assumption is correct. And it is in compression. And the member is in compression, and the member is in member or joint, whatever it is, and the member or joint, whatever it is, both. The member or joint is in compression. Otherwise, what do you mean by otherwise? If it comes negative, otherwise it is under tension. Okay. The last point. Any paper you see, sir, if there's a problem from truss, the most preferred question is this one. I don't know why. Even in GATE, they ask you 2 times, I remember. 2 times pakka, sir. More than that, I don't know. Truss algebra. What is this truss algebra? Please, all of you see here. This is my basic truss element. Right? So, how many members are there? How many joints are there? 1, 2, 3 members. 1, 2, 3 joints. Am I right? Now, I'm increasing this. This is also a truss triangular framework. Right? So, how many members are there? 1, 2, 3, 4, 5 members. How many joints are there? 4 joints. Now, if I further increase, now how many are coming? 5 plus 2, that is 7 members. And how many joints are there? 5 joints. If I further increase, how many are coming? 9, 6. If I further increase, 11 and then 7. See, 7, 11 members. Okay, that means for 2 members increase, there's getting only 1 joint, right? That means how are they related? M and J are related. M is proportional to 2J. And what is the relation? What is the relation between this M and J? From this, what's the relation between this M and J? M is how much is proportional to 2J, but there is a constant. What is that constant? See, 3, if suppose you take the first case, 3, I'll say 3 2s are 6, 6, 3, difference is 3, 3 4s are, 2 3s are 6, difference is 3, 2 4s are 8, 8 5, difference is 3, 2 5s are 10, 10 7, difference is 3, 2 6 are 12, 12 9, difference is 3. Always it is excess by 3. Are you getting me? So what is that going to happen? M equal to 2J minus 3. Now check it out. Substitute J 3. 2 3s are 6. 6 minus 3. 3 members. J equal to 4. 2 4s are 8. 8 minus 3. 5 members. 2 5s are 10. 10 minus 3. 7 members. Okay. So what's the relation between members and joints? What's the relation members for members and joints? M equal to 2J minus 3. M equal to 2J minus 3. So if a truss is satisfying this condition, M equal to 2J minus 3, we call it as a statically determinate truss. We call it as a statically determinate truss. Statically determinate truss. What do you mean by statically determinate truss? I told already what do you mean by statically determinate beam. Number of equilibrium equations are sufficient to find out the unknowns. Okay, so if the number of unknowns is exactly equal to number of equilibrium equations, then it is known as a statically determinate truss. It is also called as just rigid truss. Just rigid truss. Just constrained truss. Just rigid truss are just constrained truss. One point is just rigid truss or just constrained truss. You remove one member from it, you remove even one member from it, it will start moving. You remove one member, it will start moving. One member also you remove, it will start moving. That's why it is just constrained, just rigid truss. Are you okay? If M is greater than 2J minus 3, what do you mean by M is greater than 2J minus 3? See, if suppose I'll take a basic truss like this. See, I have connected. I have just taken a truss like this. Now what I did is m greater than 2j minus 3. Here how many are there? 1, 2, 3, 4, 5 members, 4 joints. 2 4s are 8, 8 minus 3, 5 joints. Exact truss. Statically determinate, just rigid or just constraint truss. Now m is greater than 2j minus 3. I want to add one more member. Let us say where to add. I will add between these two. Now see. The length from here to here, because already it's a structure, the length from here to here is already fixed. The length from here to here is already fixed, L. Are you getting me or not getting me, right? Now, but the member I am adding may not be having exactly that L, right? I may add a member having a length more than that or less than that. So what happens because of that? Which one I prefer? What happens is, see, if suppose I want to apply a 100 Newton compressive load. If I want to apply on this truss 100 Newton compressive load, then what I do is I will take a member which is having length L less than this. I'll take a member which is having length less than this. What happens if it is less than this? I have to elongate and keep it. I have to elongate the member. This is the extra member. I have to elongate and keep it. Sir, if it is already elongated and kept, I have taken a member which is having a length less than this. Elongated and kept. So what will happen? It is under tension. Now I am using this truss for bearing what load? Compressive load. Compressive load. See, already the member is under tension. Now if I compress it, it will come closer and the tension will become lesser and it will become 0. Then if you cross beyond that, then it will increase. That means it has made the truss to bear more load. It made the truss to have more load. That's why it's called as, what is that? That's why it's called as over rigid. This is only just rigid, but it is over rigid, and there are more members. Even if you remove one member, still it will be like a truss. So it's called as over constraint truss, over rigid truss. But the problem is number of unknowns are greater than equilibrium equations, and hence we call it as, what's that? Statically indeterminate, because static equilibrium equations are not sufficient. Statically indeterminate truss. Why I'm calling it statically indeterminate truss? Because static equilibrium equations are not sufficient to solve it. Okay, but what's the advantage with this? Why I go with this is because it can be pre-stressed. That means either pre-compressed or pre-elongated. That's what we call stressed beams. What do you mean by pre-stressed beams? They will be stressed in the opposite direction to which the load they have to bear. So that when you apply the load, they will nullify it. So that what will happen? They will have the capacity to take more loads. That's why they are called as what? Pre-stressed, right? So that's why it's also called as what? Was that not just, this is, that's why it's called as over rigid truss. Because there are more members, over rigid or over constraint truss. But this is not there for our syllabus. Why we don't have a syllabus? We have only statically determinate trusses. Okay, so those whatever is there, that will be there in your higher level of the subjects. Okay, for the timing mechanics is only milk. I have only statically determinate truss. Okay, equilibrium equations are sufficient to solve it. It's a just rigid or just constraint truss. If you have more members than m equal to 2m, that is 2j minus 3, that is called as statically indeterminate truss, over rigid or over constraint truss. It's preferred. Why? It is having the capability to bear more loads. Are you okay? See, there is no joint here, sir. There is no joint here. See, there is no joint here. Okay, don't forget that. If the last one, if m is less than 2j minus 3, if m is less than 2j minus 3, what happens? If m is less than 2j minus 3, see, in this, the same truss you take, This is a just rigid or statically determinate truss. In this truss, I am removing a member. In this truss, I am removing a member. Now what happens? See, it's not a triangle. It's not a triangle. Now it can move. It can move. Okay. So hence it's not a structure. It's not a structure. Whether what happens if it's not a structure, whether it's a mechanism or not, now I cannot say. For civil people, you don't want it. Mechanical people will see that which is a mechanism, which is not a mechanism. Then I can call it as a mechanism in theory of machines, right? But now for the timing, I'll say it's not a structure. It's not a structure. So I am not worried if m is less than 2j minus 3 or if m is greater than 2j minus 3. I am not going to take them now. Only the thing which I am going to deal in my complete syllabus is m equal to 2j minus 3, which is called as a statically determinate truss. Okay. So I don't know, sir. In many exams, even though the relation is just m equal to 2j minus 3, people think that you are forgetting or what, I don't know. In GATE itself, they ask you that relation 2 times, and in every competitive exam, like 4 years once or 3 years once, I'm seeing this question being asked. Okay, so don't forget what is the relation between m and j? M equal to 2j minus 3. Even in 2014, when I have written, I have this question. Okay, hope you have gained some knowledge from my lecture. If you feel so, please subscribe to the channel. Please leave your valuable feedback and doubts in the comment section. For my complete video lecture series, enroll in OCTEMY. Thank you. Let's catch you soon in OCTEMY. Have a good day.